Hey, what's up everybody? Welcome back to No Pros Garage. Today we're going to talk about voltage drop testing. What it is, how to use it, and why you need to learn it. Stay tuned and we're going to show you how to get it done. Okay guys, so here we are at the circuit board, and what I got here is a circuit board. It's called Snap Circuits. Okay, it's made by a company called Elenco, E-L-E-N-C-O. If anybody's interested in getting them, they're a fantastic learning tool. They have come with books that show you can make all different kinds of projects. They have fans, resistors, switches, lights, and all kinds of other stuff. So I'll drop a link in the description if anybody's looking to pick them up. They're awesome for learning. So today, what we're talking about, voltage drop. Okay, what is voltage drop? Well, basically in layman's terms, it's the premature loss of voltage. Okay, you're going to lose your voltage somewhere along your path of a wire, or for some reason, there are multiple, but for some reason, you're going to prematurely lose that voltage before it gets to the load that you're trying to power up. Okay, typically it's green corrosion. Sometimes it could be, let's say the wire in question has like 30 strands of wire, which I don't know if anybody knows the exact number. I highly doubt it, but I certainly don't. So let's just say for argument's sake, you have 30 strands of wire, and maybe half of them are broken. So now what's going to happen is that's going to cause a major source of resistance, which is going to lead that voltage to be dropped and not be able to make it to the load. So for argument's sake here, we have two AA batteries that are powering this small simple circuit. We got a switch, we have our wiring, so to speak, and we have our load, which is a fan. So each one of these AA batteries is about 1.6 volts for a total of 3.2 volts, okay? This is no different than checking across your battery on your car where you would read 12 or 12.6. We're reading 3.2 here, okay? Very simple. So now voltage drop. What is it? How do you check it? Well, it's very simple. What you want to do is essentially you want to check the same side of the circuit. You want to check, and as funny as it might sound, you want to check positive to positive, right? And right now we're seeing a difference in voltage because our switch is open. So first important thing to remember is that a voltmeter measures difference, okay? It measures the difference between this point and a difference between this point. So right now, when you check your negative to positive on your battery terminal, you are reading the difference between the two of them. When you do voltage drop, for there to be any voltage drop, for voltage drop to occur, there has to be current flow. Okay, for right now, we have an open switch. That means there's no current flowing, which means we will see no voltage drop. However, the reason we are reading right here the full 3.2 volts is because this switch is open. So it's no different than reading the positive and negative terminals of the batteries, right? So now let's see what happens when we switch this circuit on. Fan comes on, okay? So now let's check our voltage drop. Remember, I said you check positive to positive, and you can also do this on the negative side of the circuit. So you want to check positive to positive or negative to negative. It's that simple, guys. The only thing that's going to be the real, I guess, trick in finding all this stuff out is moving your one lead down that circuit until you find your problem. So theoretically, you want to keep one lead, which is typically going to be your positive lead, on your battery, and the other one is going to walk down the circuit in question and see where you find your problem. So anything on automotive, I'd say anything about 100 millivolts, maybe 150 and higher is something to, depending on the type of problems you're having, is something to probably look at, okay? Anything below that, 100 millivolts and less, chances are it's just something normal. And listen, you're always going to have a little bit of voltage drop because you have a connector on the end of a wire. You might have a very long run of wire. There might be a tiny bit of corrosion starting. There's multiple reasons that you can have voltage drop, but you're always going to show a little bit. So on the positive post to the first post, remember before we came here, we were reading the same thing we're reading now, about 1 millivolt. When we came over here before, we were reading the full 3 millivolts, or the full 3 volts, excuse me. Now we're reading 28 millivolts. That's nothing. Excuse me, my voltmeter leads keep sliding off these pins. Anyway, so we're reading 27 millivolts. That's nothing. That's, you know, obviously you can tell the fan is working, and the fan is working good. So now if we go to this is still theoretically the positive side of the circuit because we haven't passed over the load yet. So now we're reading 29 millivolts. So what happens when we go through the load and we check the other side of the load, which would be the ground side of the load? Well, we're going to have dropped all of that voltage across that load. That's Kirchhoff's law. He says the sum of the source of the voltage, in this case 2 AA batteries equaling 3 volts, that sum, that entire 3 volts needs to be dropped across however many loads or resistors are in that circuit. In this case there's one, that's the fan. So when you check the beginning part of the circuit and you check your end part of the circuit, you should drop all of the source voltage across that load. Okay? As you can see here, everything's working fine, and it does. Well, now let's shut it off for a second and let's incorporate a little bit of a problem. I have here a 100 ohm resistor. I don't know how well if that's focused or not, but you got to trust me. It's a 100 ohm resistor, okay? We're going to take out one leg of the circuit and we're just going to put this resistance in. Now what this resistance is going to do is, obviously here for demonstration purposes, we know that that's a resistor. We know that that's going to create resistance, but you have to visualize this being in the car where you're not going to see this resistor. This is going to be a wire that's buried in a harness somewhere underneath your exhaust manifold, or tucked up on top of your frame rail going on top of your gas tank, where you have to get a little bit creative in how you're going to test these. But once again, this test is very simple. You go from positive to a positive side of a sensor, of a light bulb, a blower motor, any of those things, okay? So we're going to check again, circuit off from positive to any point on a positive path. And right now you're going to see your full 3 volts because, once again, our switch is open. So theoretically my black lead is theoretically on a ground side. That's not exactly explaining it right, but the ground is passing through the load and reaching up to this point where my black lead is, even though when the circuit is on, that would theoretically be the positive side of the circuit. Okay? So let's turn the switch on and you're going to see the fan's not going to turn on. And that's because that resistance is too high for these battery source to overcome to make it to the load. So now let's check our voltage drop here. So we'll go to our beginning point. You're going to see no voltage drop, 0.3 millivolts. Go on the other side of the switch, 3 millivolts. Did I say 0.3 first? Was that right? Yeah, 0.3 millivolts. On the other side of the switch, it's 3 millivolts. Then we can go before the resistor, 4 millivolts. Now let's see what happens after the resistor. And once again, it's very important to remember that current is flowing now because I have the switch on. Okay, so after the resistor, look at that. We dropped all 3 volts across that resistor. There's nothing left to make it to the fan. And again, I'll stress this again. Imagine that this resistor, that you don't know that this is a resistor here. So you are going to be working your way down a wire to check this. So you can check multiple points. You can check before a sensor. You can poke a wire, liquid electrical tape over it to close the hole back up and seal it properly. And you can just go down the line and test all your points. And another thing to remember, the closer to 0 volts or 0 millivolts that you get on a voltage drop test, 0 is a good number. The closer to 0 you are, the better. So right here, 0.4, let me turn this light back on. And whoops, let's put this fan back on. We're breaking everything over here. All right, so we got 0.4. On the other side of the switch, we got 3 millivolts. Now, like I said, now you go down the line and you check multiple points. 3 millivolts, you still haven't found your problem yet. 4 millivolts, you haven't found your problem yet. Well, now you get to the other side of your bad wire, and there you go. You dropped, imagine on a car, that's 12 volts, not 2.9. Now you dropped all 12 volts across that. Well, you got a major wiring problem. But what you also just told yourself was that you kind of have a decent idea where it is. You checked from here all the way up to this point, and you have no problem. You checked from the battery all the way up to this point, and you have no problem. As soon as you got to this point, you have your problem. So now you know that your problem is between this point and this point. And you also know that it's on the positive side of your circuit. You can do that same test on a negative side if you're unsure. It's a very good way to isolate everything out, okay? So now that we've seen that that didn't work and that will cause all your voltage to be dropped across that resistor, and don't get it wrong, guys, depending on how much resistance you have, 100 ohms for this circuit's a lot of resistance. Of course, the fan's not going to work. Your problem might be that you have a tiny bit of resistance and your light bulb is dim instead of bright, which I'll give you a good example of that real quick. Let's get rid of this fan for a second. Okay, and we are going to put in a light bulb in its place, and we'll just put a regular circuit back. So now we have a good circuit, right? We know there's no resistance. We know there's no problem. Let's turn it on, and you can see how bright that light lights up. Now let's check our voltage drop again, right? We have nothing, 1.6 millivolts. Let's check the right before the light, 29 millivolts. Now, Kirchhoff's law says that by the time we get back to ground and we pass through our load, we will have used up all of that voltage. So here you go. After the light bulb, we used up all 3 volts. Now, the reason I'm showing you this is, now watch this. So we're going to take this leg of the circuit out. We're going to put our light bulb in that place, okay? We're going to put our fan back in here. Okay, and now we're going to do that same test again, and what you're going to notice is both of these components are going to work. Now this may be a issue like you're having, like I said. So we're going to turn this on. You're going to see the light is immediately so much dimmer than it was when it was the only load in this circuit, and the fan is also spinning slower than it was earlier in the circuit without any problems, okay? So now let's go and let's check our voltage drop. So from positive to before our first resistor is 15 millivolts. Now remember, guys, this is not necessarily a light bulb in terms of what you are trying to visualize in your car. This is theoretically, let's say, just a broken wire that's consuming some of this voltage. So now you get to this point, you have 15 millivolts. You checked all of these and they're all low. Remember, closer to 0 is a good number for voltage drop. So all of these are low, very low millivolts. They're not problems. Now you get to this point in your check, you drop 1.2 volts. That's a whole lot of voltage that you just lost due to corrosion or broken wires or whatever the case may be. That's taking a lot of voltage away from this fan, that this fan needs to work properly. Okay, so now you dropped 1.2 volts here. It's probably going to be the same before you reach the next resistor or load. You got 1.2 volts. And now you're going to see when we check the other side of this fan, we have dropped the entire 3 volts across that. because by the time, remember Kirchhoff's law, by the time you get back to the negative post of the battery, you will have, your circuit will have consumed all of the source voltage. Okay, and it's really that simple, guys. It's really that simple. You check positive to positive or negative to negative. And it doesn't matter, typically you want to leave, it doesn't matter how you do it. You might just get a, let's see if you get negative numbers if we do it this way. Nope. So it doesn't matter, guys, if you put your, oh, you are getting a negative there. Did we get it before? No, we didn't. Okay. So it doesn't really matter how you put your leads. Typically, though, it's just good practice to get into to always leave your positive lead on the battery, whether you put it on the negative side or the positive side. Leave your positive lead on the battery and move your negative lead down the circuit at multiple points until you find your issue. Okay? So like I said, imagine, you know, this is simple because we can see the problems, but imagine you couldn't see this light. You just have to check multiple spots. That's how simple voltage drop is. I can't stress it enough. It is a absolutely fantastic method to use and learn. It beats ohm meter any day of the week. Ohm meters have their place. They really do, but it's not a go-to. Voltage drop is a go-to, and if you learn it and you get good at it, diagnosing things is going to be simple. It's going to be no problem for you whatsoever. There are a lot of other aspects that go beyond the scope of this video that make diagnosing things simple, right? If it was easy, everybody would be able to do it, and it wouldn't be as in demand as it is, and it wouldn't be such a lucrative field. But it's not hard. You got to learn your fundamentals, and voltage drop this is key. If anything I said in this video doesn't make sense to you, or you want me to go over anything again or show a more complex circuit in another video, please let me know. I got whiteboards here. I can draw out circuits. I got many other components to this kit. Again, if you guys are interested, I'll link it in the description below. I have many components that I can add extra resistors. I can put in different types of switches. If you guys want to see something more complex, let me know. Hopefully this gave you the basics and got it to a point where voltage drop is easy for you to understand. Remember, you are just measuring the same side of the circuit, positive to positive, negative to negative, and you just move the lead that is not on your battery. You just move that down the line of whatever circuit you're testing, whether it be injectors, headlights, sensors, anything under the sun. It all works the same. And yeah, with that being said, guys, let me know if you like this video. Please give a thumbs up, you know, like, subscribe, and share. And if there's something I confused you on, please leave me a comment. Let me know what I did wrong, what you guys think I can do better, or how I can help you understand a little better. I'll either make another video, or I'll correct some stuff in the comments section, whatever works best for you guys. Again, I appreciate you watching, and I hope you learned something from this video. Thanks a lot.